This is moles worksheet number 3, and in this worksheet we are going to introduce another definition of a mole. So far we have said that 1 mole is equal to a molar mass, which we calculate and has units of grams per mole and is different for each compound. But in this worksheet we are going to talk about how a mole really means a definite number of things. So I want you to think of a mole as a term kind of like a dozen, right? If I ask you, how many eggs do you have? If you have a dozen eggs, everybody should be able to tell me that that means 12, right? It's a definite number of things, no matter what thing you're talking about. If you have a dozen dump trucks, you still have 12 dump trucks. So a mole is a lot more than 12. A mole is 6.02 times 10 to the 23rd. So if you think about scientific notation, what that means, that is a really, really large number. So a mole of carbon has 6.02 times 10 to the 23rd atoms of carbon. Right? And the reason we say it has atoms of carbon is because carbon is a single element, so we refer to its units as atoms, right? Now, sometimes we talk about molecules, right? So water, for example, is made up of more than one atom. It's made up of 2 hydrogens and 1 oxygen. And so it's not an atom, it is a molecule. So when we talk about 1 mole of water, it still contains 6.02 times 10 to the 23rd, but this time it contains that many molecules, not atoms. Right? Same for our diatomic, our Hofbrinkel molecules. We refer to those as molecules, not atoms. Okay, now, the thing that's important to remember is that if you have a mole of carbon and a mole of water, you have the same number of each of them, but they don't necessarily weigh the same amount. They have different masses, right? Because when we calculate the molar mass of carbon, it is less than when we calculate the molar mass of water. So think back to our comparison to the term a dozen, right? You have a dozen eggs and a dozen dump trucks. So you have the same number of eggs as dump trucks, but they certainly don't weigh the same amount, right? You should all be able to tell me that a dozen dump trucks weighs a whole lot more than a dozen eggs. Okay, so you have the same number of them, but you don't necessarily have the same weight or the same mass of them. Now, before we get to the problems, we have to give just a little shout out to our friend Avogadro. 6.02 times 10 to the 23rd is something that I will refer to as Avogadro's number in honor of the Italian professor, actually of physics, but physics and chemistry sort of double dip sometimes, Amedeo Avogadro. So, our new definition, our second definition that we'll end up with 3 of a mole is that 1 mole is equal to 6.02 times 10 to the 23rd atoms or molecules, depending on what we're talking about, and I will call that Avogadro's number. So, moving down to our examples. We have an example that's going to show you how to do problems 1 through 5, because problems 1 through 5 are all asking you to solve for molecules, right? So, in our first example up here, we are given a number of moles of water and asked to find the number of molecules. So we set this up like a factor label. I want to know the number of molecules. I've been given the number of moles. And every single time I do a factor label on this packet worksheet 3, I'm going to set up a fraction that has 1 mole on one side of it and Avogadro's number of molecules or atoms on the other side. And the reason I've put 1 mole on the bottom here of my fraction is because it allows me to cancel out moles. And so I do my multiplication. right? 3 times 6.02 times 10 to the 23rd. Now, a little note on calculating here. You have to be very careful when you put a number in scientific notation into your calculator. If you have a button that looks like this on your calculator, this is your very best option for entering a number in scientific notation. This is the best way to communicate with your calculator that 6.02 is not getting multiplied by 10 to the 23rd, but that 6.02 times 10 to the 23rd is a number that you're referring to in scientific notation. So if you have that button and you want to enter Avogadro's number into your calculator, all you have to do is 6.02, then hit the EE button, because the EE button basically stands for times 10. And then, after that, you enter your exponent, 23. Okay, so if you put that in and you hit enter, your calculator's just going to read 6.02 E23. And then you can go ahead and multiply by 3 and make sure you get your answer. Now, let's say that you do not have an EE button. Okay, in that case, you're going to have to just be a little bit more careful when you enter these numbers that are in scientific notation. And by more careful, I mean you need to use parentheses. So you're going to put parentheses 6.02 times 10, and then you're going to use what we call the caret key. This little caret key has an up arrow on it, and then 23, and then you need to end with parentheses. Okay, but if you don't put parentheses, you're sometimes going to run into trouble, especially when you start dividing on the next worksheet two numbers in scientific notation by each other. You'll end up with, like, you might have the 1.81, for example, but it'll be times 10 to the 47th or times 10 to the 48th power, which is way off. Okay, so be careful with those. But if you can follow this example, then you can do problems 1 through 5. If we look at our next example, let's get this back over here. Our next example is going to show us how to do problems 6 through 10, which are basically the reverse of the first 5 problems, because this time we're trying to solve for the number of moles. So in this case, right, we are given the number of atoms, because it's a single element neon we're talking about. Right? If it had been water, we still would have said molecules. And we're asked to find the number of moles. So what we want to find is set equal to what we have been given, and we're still going to make a fraction out of this definition up here, but this time we're going to flip-flop it. We're going to put the 6.02 times 10 to the 23rd on the bottom and the 1 mole on the top, because that allows us to cancel out. All right, so if you compare the fraction that we made up here with the fraction that we're making down here, you can see that they're just the flip-flop or reverse of each other, so that we can cancel out the units we want to cancel out. So here is an example now where I am going to have to enter this 2.408 times 10 to the 24th into my calculator, and then divide it by 6.02 times 10 to the 23rd. So if you're working with a caret key up here rather than the EE button, you need to be very careful that both of those scientific notation numbers go into parentheses, and make sure that you do get a final answer of 4, not 4 times 10 to the 47th or 4 times 10 to the 48th. If that's what you're getting and you can't figure out how to fix it, then we definitely need to look individually at your calculator the next time that you are in class. So follow that second example for problems 6 through 10 when you get into class next.